Hello, good day viewers. Still on inequality. Today we have this simple problem. We would like to find the range of possible values of x that can satisfy this inequality, x minus 4 divided by x plus 5 less than or equal to 4. Alright, before we start, you should know that x can never be equal to negative 5, because if x is negative 5, the denominator will be equal to 0, right? And the whole system will be undefined. So we know that x cannot be negative 5. And secondly, we can assume the whole of this as an equation. So let us write it as an equation: x minus 4 divided by x plus 5 equal to 4. And since we know that the denominator is not equal to 0, we can multiply both sides by the denominator. So we multiply the left hand side by x plus 5. We do the same thing, x plus 5 to the other side. From here, this will cancel this. To the left hand side, we have x minus 4. And to the other side, if we distribute, we have 4 times x is 4x. And 4 times 5 is 20. If you take 4x to the left hand side, it becomes negative. You take negative 4 to the other side, it becomes positive. So we have x minus 4x equal to 20 plus 4. And this is negative 3x equal to 24. We divide both sides by the coefficient of x. X will be 24 divided by negative 3. And this will give us negative 8. So we have two critical points that we are going to test on the number line. We have negative 5 and negative 8. So let's test them here, but let me bring back our equation or inequality. Here is the inequality. Then we have our number line. The critical points we have are negative 8 and negative 5. Negative 8 is less than negative 5, so it should be to the left hand side. We have negative 8 here, and we have negative 5 to the other side. Let us test these two values. Already we know that negative 5 cannot satisfy the inequality, because if you substitute it here, the denominator will be equal to 0. So let us make an open cycle here. What about negative 8? Let us plug it here. If you plug in negative 8, we have negative 8, negative 4 to the top, which is negative 12. So we have negative 12 to the top. To the bottom, we have negative 8 plus 5, that is negative 3. So we have negative 3. And if you divide this, you're going to have exactly 4. And 4 is indeed less than or equal to 4, so it's satisfied. So we have a closed cycle here, indicating that negative 8 is a solution. Next, we need to test values to the left hand side of negative 8, in between negative 8 and negative 5, and also to the right hand side of negative 5. Let us choose nice numbers. We have negative 9 here. We could have negative 6 here. And we could have 0. 0 is greater than negative 5. Alright, let us test these three values. For negative 9, if you replace x with negative 9, you have negative 9, negative 4, which is negative 13. So let me write it here. Negative 13 divided by negative 9 plus 5. That will give us negative 4. So we have negative 4 here. And this is finally 13 divided by 4. And what is 13 divided by 4 in decimal? It is equal to 3.25. And of course, 3.25 is less than negative 4, right? So all values to the left hand side of negative 8 will satisfy this inequality. So let us tick it. So all values to the left of negative 8 will satisfy all of them. Now we choose a value in between negative 8 and negative 5, which we have here as negative 6. So what happened? Negative 6, negative 4 is negative 10. negative 10, negative 6 plus 5 is negative 1, so we have negative 1 here. If you divide, you get positive 10, and positive 10 is not less than 4. So no value in between negative 8 and negative 5 will satisfy this inequality. And lastly, we have to the right hand side of negative 5, which we have 0. So if you plug in 0 here, 0 minus 4 is minus 4. And 0 plus 5 is 5. And negative 4 divided by 5 is negative 0.8. And negative 0.8 is indeed less than 4. Therefore, all values to the right hand side of negative 5 will satisfy this inequality. Like 1, 2, 3, all of the values to the right hand side. So you can clearly see our solution is from negative infinity way down to negative 8, including negative 8, and from negative 5 all the way down to positive infinity, excluding negative 5. So let us write down the solution. Therefore, the solution to this inequality is x belongs to the set of values from negative infinity down to negative 8, including negative 8. So we use this square bracket to indicate that negative 8 is a solution, union from negative 5, because negative 5 is not a solution, we use parentheses, negative 5 way down to positive infinity, parentheses. You know, for infinity you always use parentheses to cover it. So this is just the solution to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.